The FMI, standing for Functional Mockup Interface Standard, proposes an interface to co-simulate elements coming from different tools. Both Simplorer and SCADE Suite support this standard. We will export a functional mockup unit, so that's named FMU, from SCADE Suite, and then import it into Simplorer. So I'm first going to create a configuration. Let's name it FMU, so I can quickly choose to come here. So this is going to appear here. I'm going to change the settings for this. In code integration, I do select my target, FMU. Okay, I have some options here to choose if I want, while doing my simulation, to record a scenario, to replay later in SCADE Suite. I can also check Enable White Box. So when I start my simulation, this is going to connect to the SCADE Suite simulator, and you will see both sides simulating at the same time in parallel. So for the moment, I will just keep the default. I will have a black box simulation. And in my compiler here, because Simplorer is 64 bits, I need to specify that I do want a 64-bit FMU. So when this is done, it's as simple as selecting my root node and press build. It generates my code, builds it, and put that into an FMU. Okay. So I can go into my project, and in the FMU directory, I do have here the generated FMU that can be directly imported into Simplorer.
So now that OpenL has generated FMU, I will just have to import it into Simplorer. And to do that, it is very simple. So I go to Subcircuit and I just select Add FMU Component. Then I will choose the right file, which is this one. Open it. And then it will create the model for you into Simplorer. So I will just now connect the interfaces. One to control my switch, and then I will just connect the information that I need to control the switch, which are the currents that goes here, and the other one, which is the motor speed, that should go here. The last thing that I have to do is to enter the different parameters for the controller. So let's do it. First of all, I have to disable the different pin for the parameters I have to enter. So that should be it. Period is 1 microsecond. Threshold
minus 2.5.
The low one is minus 2.5. DT is also 1 microsecond. And that's it. After that, I will just have to set up the transient simulations and then the different reports that we want to observe after the simulation. And now I can just run the simulation. So I just go to Analysis, right-click, and Analyze. And now the simulation is over, and I can have a look at the results. So I can here observe the command sent to my switch. And what I can see is that when the command is equal to 1, the current rises into the motor as the transistor lets it flow. And when the command is equal to -1, well, the switch is blocked, and then the current drops. And here we can see on the current waveform the hysteretic effect, which is regulating the current here. And the regulation goes on until the speed, the regulation speed is not reached. So this is what you can observe here on the plot of the rotor speed of the machine. And this waveform, this behavior is actually expected since we haven't put any load on the electrical machine.
In two very simple steps, we have seen how straightforward it is to run a SCADE-generated controller in Simplorer. It enables early prediction of the behavior of a complex system, including its software parts. Simplorer plant model can be enriched with more complex simulation models, including reduced order models or co-simulation with many other 3D ANSYS tools. The software component used for the simulation will have the exact same behavior on the actual target, as it is rigorously the same application code.